Okay, this is Math 2, Unit 8. This is the extra worksheet. There's actually, let's see, 32 problems on the worksheet. You were not assigned to do all 32. You were just assigned to do the ones that are circled, so I'm going to go over the circled problems only. Okay, so in numbers 1, 2, and 3, we're going to write the expression in radical form. So anytime you're asked to put something in radical form, that means you're going to have the radical symbol. And then if you have the expression in exponential form, you take the base of the exponent, you put it right here in the radicand spot. You take the numerator of the denominator, which is 3, and you put it in the index spot. And then you take the numerator of the exponent, which is 1, and you're going to put it as the exponent to the radicand. So this would become the cube root of x. You don't have to write the x to the 1 power. That would be number 1. Number 2, same idea. To put this problem to put m to the 1/5 into radical form, we put the radical, we take the base m, we're going to put that in the radicand spot. We're going to take the denominator, make that the index, and then we're going to take the numerator of the exponent 1 and we're going to put it right there. And once again, you don't have to ever write an exponent of 1. Number 3, k to the 3/2 or 3/2 power. Putting it in radical form, the k would become the radicand, the 2, the denominator, becomes the index, and then the 3, the numerator of the exponent, will become the exponent for the radicand. Now in this particular problem, whenever you have an index of 2, you don't have to write it, it's implied, so you would just write number 3 as the square root of k to the 3rd power. Okay, skipping down to numbers 12, 13, and 14, we're going to write the expression in exponential form. So you can see we are given a problem in radical form and we're going to write it in exponential form. So essentially we're going to do the opposite of what we did in numbers 1, 2, and 3. So in radical form, to change it into exponential form, we take the radicand, which is 7, and then we're going to have that to a power that's going to be a fraction. The index becomes the denominator of the fraction for the exponent, and whatever that radicand is to the exponent of, that becomes the numerator. So number 12, 7 to the 4/5 power. Number 13, we have the 4th root of 5x to the 3rd power. Now in this particular problem, if you're not given parentheses inside for the radicand, what this means is that that 3rd power is really only for the x. That 5 has a power of 1. So now when you change this into exponential form, we're going to have a 5, and that's going to be to the power of 1/4. And then we're next to it, we're going to have an x, and the x is going to be to the power of 3/4. Okay, so you got to be careful on a problem like number 13 when the radicand, you have an exponent but it's not in parentheses. Okay, then you have to treat each element of the radicand as having different exponents. Number 14. Pretty straightforward one in number 14. We're going to take the radicand, that becomes the base, and then it's going to be to the power of 3/5. Okay, so that would be how we do those. All right, next 3 problems we're evaluating the expression of number 17 and 18 and 22. Remember, the word evaluate in math class means that I want an answer. Okay, so this means give a numerical answer. So what we're going to do whenever we're asked to evaluate a problem that is in exponential form, such as number 17, which is 8 to the 1/3 power, the first thing that you do is you rewrite the problem into radical form. So you do exactly what you were doing on numbers 1, 2, and 3. The base will become the radicand, the denominator of the exponent will become the index, and the numerator of the exponent will become the exponent for the radicand. And that's going to be a 1, so I don't have to write that. Okay, now, you're not done when you're evaluating, because evaluating, there's going to be a couple more steps, most likely. The next step is that you're going to take the radicand 8 and you're going to make a factor tree out of the radicand. So 8 factors into 4 times 2, and you keep factoring until we have nothing but prime numbers. So this is called a prime factorization. So what we just found out is that 8 factors into as a prime factorization of 2 times 2 times 8. And after you make the factor tree, then what you do is you're going to rewrite your radical, okay, with the same index, but instead of the radicand, you're going to write the factored form of it, which is 2 times 2 times 2. And then you're going to simplify that radical right there. So the way you simplify it is you take a look at the index, which is 3, and what that index tells us is that we need 3 identical numbers in order to simplify. So you can see we have 3 identical 3's, and whatever there is identical of, those numbers must go to the outside, and they go to the outside of what they're identical of, which is a 2. Okay, so now you're done. And then your answer is, we have a 2 on the outside, and then if there's no leftovers underneath the inside the radical sign, that's actually your answer. So number 17 would simplify to 2. 8 to the 1/3 power evaluates to make 2. Okay, same concept in number 18, 9 to the 3/2 power. So the first thing that we're going to do is we are going to convert it into its radical form. The 9 is the radicand. The 2 becomes the index. I don't have to write an index of 2, that's implied. And then the 3 becomes the exponent for the radicand. Okay, now you're not done, because now we have a couple more steps. Remember, our next step is we have to take the radicand and we have to make a factor tree. 9 factors into 3 times 3, and we keep factoring until we get prime numbers. That's called a prime factorization. Okay, so now our next step is, and this is the step that people don't like, but it's a pretty necessary step. You're going to take your radical and you're going to write it in its expanded prime factorization form. So 9 is 3 times 3. However, now that exponent of 3 tells me that I need 3 3 times 3's. Once I do that, I'm ready to simplify. My index is 2, so my index tells me I need 2 identical numbers. And every time I see 2 identical numbers, those identical numbers must go outside the radical. So I have a second set of identical 3's here. Those must go on the outside. I have a third set of identical 3's. Those must go on the outside. And then you multiply the numbers on the outside together. 3 times 3 times 3 is 27, and that is your answer because there is no leftovers. So then your answer is just what those multiply to. All right, number 22, same concept. We're going to take 81 to the 3/4 power. In order to evaluate it, we're going to change this into radical form. So we're going to take the 81, we're going to make it the radicand. The index is going to be 4. And then my 81 is going to be to a power of 3. My next step is to take the radicand, 81, and then you make a factor tree out of 81. Okay, 81 factors into 9 and 9. 9 factor, those aren't prime yet, so we got to keep factoring. 9's factor into 3 and 3. And 3's are prime, so we have our prime factorization. Okay, then once again, my next step is the step that many people don't like, because you have to write out the factored expanded form of your 81. 3 times 3 times 3 times 3. My index is still 4, but I have to write that 3 times 3 times 3 times 3 3 times, because my exponent for the 81 is 3. And once I do that, I'm ready to evaluate. So my index is 4, so I need to look for 4 identical numbers, and every time I have 4 identical numbers, those numbers must go out of the radical. So you can see I have a second set and I have a third set of 4 identical 3's. So on the outside, I'm going to have 3 3's. that 3 from that set, that 3 from that set. There are no leftovers, so my answer is just going to be whatever these numbers multiply to make. 3 times 3 times 3 is 27. So there's your evaluating of 81 to the 3/4 power. Okay, moving over to the other side, you were asked to do numbers 29 and number 30. So in number 29, we are going to simplify, and then we're going to label our answer as rational or irrational. So in number 29, whenever you're adding problems together that have grouping symbols, the first thing you want to do is you want to rewrite the problem so that there are no grouping symbols, the parentheses. So you go to first parentheses and you say to yourself, okay, well there's a 1 in front of that parentheses, and if I were to distribute the 1 into both members of the grouping symbol, what would that become? Well, it would become 5 plus 2 radical 17 without the parentheses. Then you go to the second grouping symbol and you say to yourself, okay, there's a 1 there and it's a positive 1, so if I were to distribute the positive 1 into the 7, what would that become? That would become positive 7. And then if I were to distribute the positive 1 into the positive 6 square root 17, that would become a positive 6 square root 17. Okay, so rewrite the problem without parentheses anytime you have parentheses when you're adding or subtracting. After we do that, now we just think like terms. So we're looking for like terms. So we can see that we have a 5, which is just a normal whole number. It is like with 7, so I can combine those together. 5 plus 7 is going to give me 12. And then, if you notice here, I have a positive 2 radical 17. I have a positive 8 radical 17. Because the radicands are the same number, 17, these are like terms. So I could add those together. And the rule is, when you add radicals, you go outside number plus outside number. So we're going to go 2 plus 6, and then you leave the radicand as it is. So we're going to get 12 plus 8 radical 17. And that's going to be your answer, your simplified version of number 29. We cannot add the 12 to the 8 because that 12 does not have that square root or radical 17 to it. Okay, now the question is this answer, should we label it as rational or irrational? And this is going to be an irrational answer, and the reason is because since that 17 is inside a square root, and anytime you get a non-perfect square number inside a square root, the answer turns out to be irrational. Okay, number 30, same concept. We have grouping symbols. So first thing we're going to do is we're going to take the number in front of the grouping symbols, and we're going to distribute it, and then we're going to rewrite the problem without the grouping symbols. So if I took the 1 and I multiplied by the 6, that's going to give me 6. Lights just went out. Now they're back on. If I took the 1 and I multiplied it by the positive 4 square root of 3, that's going to give me a positive 4 square root of 3. When you go to the second grouping symbol, we have a 1 here, but it's a negative 1. So if you took the negative 1 and multiplied it by the positive 8, that's going to give you a negative 8. Then if you took the negative 1 and multiplied it by the positive 4 square root of 3, a negative times a positive is going to give you a negative 4 square root of 3. Okay, now once we have no grouping symbols, we're going to combine like terms. Think like terms. The 6 is like with the negative 8, so 6 minus 8, negative 2. Then I have the 4 radical 3, the positive, and then I have the minus 4 radical 3. Well, these are like, I think of it as like terms, and so then what do? I'm going to go outside plus outside, but if you notice, I really don't have to do anything with these because these are complete opposites of each other. So when they're complete opposites of each other, they just cancel each other out, so that leaves my answer as negative 2 for number 30.